Hi friends, this is Silver Homeschool. In today's video, we're going to look at the length of arc of a circle. Length of arc of a circle. Now, the arc of a circle, if you have a circle, the arc of a circle is that part of the circle which is cut out by two radii. This is your radius. We'll take this place to be the center of the circle. Let's call it O, the center of the circle. You see this very part of the circle or part of the circumference that is cut out by this very radii. This is what we call the arc of the circle. Let's mark here to be our point P. And this very point where this radius cuts this circumference, we'll call it point Q. Now, the distance between point P to point Q is what we call the arc of the circle. So this very portion of the circumference which is cut out by two radii is what we call the arc of the circle. An arc of a circle can also be formed when a chord cuts out a portion of the circle. Take for instance, you have a chord. This is a chord. Let's call here point A. This very point, you call it A. And this very point where the chord touches the circumference at this very part, we call it B. Now, the arc of this very circle is not a distance from A to B. We call it the arc of the circle. So it is a portion of the circumference which is either cut out by two radii or it is cut out by a chord. In our previous videos, we looked at parts of a circle. We looked at secant, sector, tangent. We looked at diameter, radius. So please, if you have not gone through that video, make sure you go through it so that you can be able to follow up in this very video. All right. In order to calculate the length of arc of a circle, there are two dimensions that must be known. First of all, we must know the radius of the circle. We must know the radius of the circle. That's the first thing that must be known in order for us to calculate the length of this very arc of the circle. We must know the radius of the circle first of all. And we must also know the angle that is subtended or that is subtended at the center of the circle. An angle is subtended at this very point. Let's call this angle theta. So two dimensions must be known. Number one, we need to know the angle at the center. That is the angle that is subtended at the center by the arc. Another thing we need to know, another dimension we need to know is the radius. Radius of the circle. So once these two dimensions are known, the angle that is subtended at the center and the radius of the circle is known, we can be able to calculate the length of this very arc. Now, mathematically, let's get the mathematical expression of length of arc of a circle. Mathematically, the length of arc of this very circle. Now, let me call here P, and here is our Q. So the distance from P to Q, let's call it PQ. That is distance from P to Q. This is going to be equal to a fraction of this very angle which is theta, compared to the total angle in a circle, 360. Okay, the total angle in a circle, of course, is 360. Now we're going to multiply it by the circumference of the circle, 2 pi r. In one of our videos, we looked at how to calculate the perimeter of a circle and the circumference of a circle. I would like you to look at the link below. This is the mathematical expression for the length of arc of a circle. With this formula, we can find the length of this very circle. Okay, let's apply this in some problems. This is a problem before us. This is a question. And this question says that we should find the length of an arc of a circle of radius 7 cm, which subtends an angle of 84 degrees at the center of the circle. Now, remember what we're looking for is the length of arc of the circle. Now, in order to approach this question, first of all, we need to make a sketch of this very question. This is my circle. This is the center. Let's take here to be the center of the circle. This is my radius. You have a radii. Okay. Now, we are told that the radius is 7 cm. Here is 7 cm. Of course, here too will be 7 centimeter. Okay. And we are also told that the arc subtends an angle of 84 degrees at the center. So meaning that at this very point, we have 84 degrees. Now, we are asked to calculate the length of this very arc. Let's mark here point P, that this very point, and mark this very point, point Q. So meaning that we are looking for the length of PQ. Now, the length of this very arc, from the formula mathematically, length of arc PQ will be equal to theta, which is this very angle, over 360, which is the total angle in a circle, multiplied by the perimeter or the circumference of the circle, which is 2 pi r. Okay, so let's write out the parameters that are given in this very question. The parameters we have are theta. Theta is given to be 84 degrees. And r, which is my radius, is given to be 7 centimeter. Another parameter that is given is pi. Of course, our pi is always known. Pi is a constant, and pi is always 22 over 7. This is always the value of pi. It is a constant. Now we can substitute all of these into this very equation to find the length of the arc PQ. So when we do that, we're going to have that length of the arc PQ is going to be equal to 84, that is the angle theta, 84 divided by 360 multiplied by 2 pi, which is 22 over 7. We'll replace the pi with 22 over 7 multiplied by r, which is our radius. Our radius is 7 cm. 7. So when we compute this, we're going to have that PQ is equal to, now we can multiply out the numerators, multiply out the denominators. Okay, so whenever you're multiplying fractions, multiply out the numerators, multiply out all the denominators together. Of course, we know that this 2 has a denominator of 1 and this 7 has a denominator of 1. Now, let's multiply out all the numerators. The numerators are the numbers on top, which is 84 times 2 times 22 times 7. Divide by all the denominators, numbers below the fraction. That is 360 times 1 times 7 times 1. So, when we multiply out what we have as the numerator, 84 times 2 is giving us 168. You can do this on your own, or if calculator is allowed, you can use calculator to do that. Multiply by 22, multiply by 7. When you do that, you're going to have 25872. Everything divided by, now we'll multiply out the denominators. When you multiply out, you have 2520. So my PQ would divide through. When you do that, 25872 divided by 2520, your answer will be 10.27 approximately centimeter. So this is how to calculate the length of an arc of a circle. All right, let's look at another question. Now the question says that an arc of a circle is 17.6 cm if the angle subtended at the center by the arc is 72 degrees. Calculate the radius of the circle. Now, of course, the first thing to do is for you to sketch this very problem. You have a circle. This is the radius of the circle. And we are not given the radius of this very circle. We are asked to find the radius. Let's mark this very radius R. But we are told that the angle at the center is 72 degrees. 72 degrees. And we are also, let's call here P, like we did in the last one, let's call here Q. Now, we are given that the length of this very arc, PQ, is given to be 17.6 centimeter. Now, remember that the formula for length of arc of a circle, length of arc PQ, length of arc PQ is equal to theta over 360 times 2 times pi times r. That is 2 pi r. Now, the parameters that we are given here is, we are given PQ, which is the length of the arc. From the question, we are given that PQ, an arc of a circle, is 17.6 cm. So PQ is 17.6 cm. And my theta is 72 degrees. What of my R? I don't know my R. We're looking for the R. Sorry, we're looking for the R. We don't know our R. We are looking for it. Now, let's now substitute the value that are given to us into this very formula here. PQ is 17.6. So I'll replace position of PQ with 17.6. I then have that 17.6 is equal to theta. What's my theta? Theta is 72. 72 over 360 times 2 pi. What is my pi? Of course, we know that pi is always 22 over 7. Please, is a constant. So times 2 times 22 over 7, which is our pi, multiplied by r. We don't know this r, we're looking for its radius. Like we did in the last problem, we'll multiply out all the numerators. This is over 1, this is over 1, multiply out all the denominators. So when we do that, we'll have that 17.6 is giving us 72 times 2 times 22 times r. Everything is divided by 360 times 1 times 7 and times 1. So when we multiply out what we have as a numerator, we then get 17.6. 72 times 2 times 22. We end up giving us 3168. 3168R. Remember, we have R here. Now let's multiply out what we have as the denominators. 360 times 1 times 7 times 1. So we have 2520. This is exactly what we have here, 2520. Okay. Now, the next thing we need to do for us to find this very r here is for us to cross multiply. Of course, we can make this one to be over 1, to have a denominator of 1. So what we're going to do the next is to cross multiply. We'll cross multiply, meaning that this will multiply this, and this will multiply this. So when we cross multiply, we'll then have that 3168r times 1 equals this multiplies this, that's 17.6 times 2520. This is exactly what we have. So when we multiply this times 1 is giving us 3168r equals, so when we multiply 17.6 by 2520, we'll get 44352. All right. So for us to find this r, which is the radius of the circle, we'll have to divide both sides by 3168. So I will say divide both sides by 3168. And once I do that, I will have 3168r divided by 3168. Remember, I said both sides. So this very side, I will also divide it by 344. Okay, so I will divide this 44352 by 3168. And once I do that, this will cancel out this. And once you divide this, you can use your calculator to do it. Once you divide these two, of course, you obtain 14. Okay, it means that the radius, since one will cancel this, we'll have r here. Radius is equal to what? 14 centimeter. Centimeter because we're initially given that the length of the arc is 17.6 centimeters. So the unit is centimeter. So the radius of the circle is also going to be in centimeter. So this is basically how to calculate the length of an arc of a circle and the radius of a circle. In our next video, we'll we're going to look at sectors of a circle, the areas of the sector of a circle. So if you have not hit the subscription button, please